Okay, we are back with day 2 of exponent laws. So yesterday we learned if we have a power. What is a power? A power is some number, which we call the base, to an exponent. Say 3 to the 4, which means it's the base, in this case 3, multiplied by itself a number of times equal to the exponent. So in this case 3 times 3 times 3 times 3, which happens to be 81. Sorry. So yesterday we learned if we multiply two powers, we keep the base the same, and we just add the exponents together. And if we divide two powers with the same base, we keep the base the same, and we subtract the power. So we've got a couple more things we're going to carry on with for this today. So first is what's called power of a power. So here, and it's tricky when it's all letters, so let's try doing it a little more concrete. So if we have a power, say 2 to the power of 4, and we take that power and we do that, let's say to the exponent 3, then what's actually going to happen is we'll keep the base the same, and we will multiply these two exponents to get 2 to the power of 12. And we've got an example of why this works over here. We kind of work outside in. So if we have 3 squared to the power of 4, that means it's 3 squared multiplied by itself 4 times. 1, 2, 3, 4. And then each 3 squared is actually just 3 times 3. So we expand those, and we get 3 times 3, 4 times, or 3 to the 8. And we'll note that 8 is equal to 2 times 4, which is from up there. So power of a power, if you have one power and it's being taken to another exponent, base stays the same, multiply the exponents. So 2 cubed all squared will be 2 to the 3 times 2, which is 6. X squared to the 4th is x to the power of 2 times 4, which is 8. And a cubed to the power of 7, base stays the same, a to the power of 3 times 7, which is 21. Now, we touched on this a little bit when we looked at fractions. So sneaking a peek down the page a bit, we did this yesterday. And that's kind of a consequence of this first one we're looking at today up here. Ooh, I like these highlighters. I should play with these more. Which is essentially just saying, if we have stuff in a bracket that's all to an exponent a, that a has to apply to each piece inside the bracket. Now this is if it's multiplying or dividing. Adding and subtracting is a whole other can of worms. We'll deal with that in future years. But for right now, if we have a bunch of stuff in a bracket that's multiplying together, and then we take an exponent, the exponent applies to each piece. Similarly with the fraction, we have things that are dividing, and the exponent applies to each piece. So let's do a couple of the examples here. So a squared b squared to the 4th. Well, the rule above is telling me that that is a squared to the 4th, b squared to the 4th. That power of 4 has to go in on each base individually. So that will be a to the 8, b to the 8, because 2 times 4 is 8. And if you don't want to write out that step, you don't have to. Just keep track that this 2 applies to every base, without exception. So it's going to apply to the 2, it's going to apply to the x cubed, it's going to apply to the y to the 4th, and it's going to apply to the z. So maybe I don't think we have to write this one out. So 2 squared is 2 times 2, which is 4. X cubed squared is x to the 3 times 2 is 6. Y to the power of 4, all squared, is y to the power of 8, 4 times 2. And z squared is z to the power of 1 times 2, which is 2. And if that's a lot all at once, this is a video. You can always rewind it and go through my logic. Look at the one before, see how everything applies. It's the same idea. We'd have 2 squared, and we would have x cubed squared, and y to the 4th squared, and z squared, essentially. Finally, we have negative 2 squared. Well, that would be negative 2 as the base, all being squared. So the negative is inside the bracket. The negative is part of what's being squared. So negative 2 times negative 2, positive 4. X cubed to the power of 2, x to the 6th, y to the 4th to the power of 2, y to the 8th. So again, fractions we did yesterday, it's the exact same idea. Apply it to every piece individually. So this means we have a squared, because it has to go in on the top, over b cubed squared, because it has to go with the b as well. Every single base. And now that is the same as a to the 2 times 2 is 4. And b to the power of 3 times 2 is 6. Power of a power, multiply the exponents. So pause here, try the next two, and then unpause to see if you got it right. So this one, I've got 4 cubed, which is 64. I've got x cubed cubed, which is x to the power of 9. And in my denominator, I've got y to the power of 5 all cubed, which is y to the 15th. Because again, it applies to every single base. Drawing the arrows can be helpful for some people as well. So now I have a product of two things, but they're both powers of powers. So this is good old bedmess, right? We have to simplify the brackets first. Well, there's nothing else I can do to the brackets. Second thing is exponents. So these have to be applied to every base inside the brackets. So we get 3 cubed, which is 27. A squared cubed is a to the 6th. And we'll just keep that in a bracket for now since they're multiplying. Then we've got 4 squared is 16. A cubed squared is a to the power of 6. And then they were multiplying here, so they're still multiplying here, right? We simplified this part, and we simplified this part, but they were multiplying there. They still have to be multiplying here. Okay, 27 times 16. I don't know that off the top of my head. That's 320 and 70 and 42. 432. That's probably wrong. I don't have my calculator, so double check that one on me. A to the 6th times a to the 6th. If I'm doing a to the 6th times a to the 6th, remember that's a to the 6 plus 6, which is 12. A to the 12. All right, so we just have a few more complex examples. Again, pause the video, try them, see how you're doing, then come back, unpause, and see how you're doing. Okay, so hopefully you've given these a shot. We follow bedmess. So first we need to do brackets. So bedmass. So let's simplify what's in the brackets. I've got 3 divided by 1, which is 3. X squared divided by x is x. 2 minus 1 is 1. Y to the power of 5 divided by y cubed. I subtract the exponents. That's y. 5 minus 3 is 2. So that's that. Canceled with that. And that canceled 3 of those. And then I still have z in the bottom because there is nothing up top to cancel with that. And all of that was squared, so all of this is still squared. Then we can apply that to all the different bases. So we get 3 squared is 9, x squared is x squared, y squared squared, y to the 4, z to the 4th squared is z to the 4 times 2, which is 8. That's the final answer for that one. Whew, we got a lot going on here. I can't simplify any brackets, so the next piece is my exponents. Now it does say I'm going to evaluate with substitution by substituting in x is 2 and y is negative 3. But it wants me to simplify first. And you should always simplify first. The more simplified you can make your equation before you start substituting, the less places there are to make mistakes. So let's see what we have to do here. Brackets are all simplified, so we go to exponents. So 2x squared is 4. X squared. 2 squared is 2. X squared is x squared. Then we have x cubed squared is x to the 6th. Y to the 4th, all squared, is y to the 4 times 2, which is 8. And that's all divided by x squared squared, so x to the 4th. And y cubed, all squared, is y to the 3 times 2 is 6. Ooh, we got a lot of steps on this one. Now we'll do our multiplication and our division. So let's do the multiplication first. 4 times 1 is 4. X squared times x to the 6th is x to the 8th. And then no y's here, so 1 just multiplies by y, 8, and we still have y to the 8. And our denominator is still x to the power of 4, y to the power of 6. And here's some simplification. I can divide the top and bottom by x to the power of 4. So that, well, let's not go that route. Let's just do our rules here. Sorry. So 4 divided by 1 is 4. X to the 8 divided by x to the 4th. I subtract the exponents. X to the power of 4. And y to the power of 8 divided by y to the power of 6. 8 minus 6 is 2. So we have y squared. And now that we're as simplified as we can be, we'll do our substitution. So we'll substitute a 2 in for x. And we'll substitute a negative 3 in for y. And here's one of those cases where it's really important to substitute with brackets, because y is going to go in as negative 3. So it's going to be negative 3 squared, not negative 3 squared, because that's a different number entirely, right? These are not the same. That is positive 9, whereas the second one is negative 9. So make sure you do your substitution with brackets. So that's 4 times 2 to the power of 4 times negative 3 to the power of 2. Again, big numbers here, and I don't have my calculator with me. We got 16 times 9, 90, and 54, 144 times 4. My brain just straight cut out on that one. What did I say? let's do some let's do it the hard way over here. So 2 times, so we've got 4 times 16 times 9. So 16 times 9, 54, and then 9, so that's 144. And then 144 times 4, we've got 16, carry the 1. It would be 16, but 1 is 17, carry the 1, 4, 5, 576. Unless I botched it, which would be really embarrassing, but hey, it's a video. I can't see you if I've done something dumb. All right, now we've got a different question. We need to express the answer 16 as a power with a base of 4. So a base of 4 means that we have 4 to the power of something is 16. Now, how would we go about doing that? Well, for me, I would just look at multiples of 4. So or powers of 4. So if I do 4 and multiply 4 times 4, that's 16. And then 16 times 4 is 64, and you can keep going as far as you need to. 64 times 4 is 256. But we don't have to go that far. We saw it's right there. So that's 4 to the power of 1. That's 4 squared, 4 cubed, 4 to the 4. So you can essentially just, on your calculator, keep doing 4 times 4 times 4 until you get to the answer. So in this case, x is equal to 2. 16 as a power with a base of 2. So this time it's 2 to the power of x equals 16. So pause, take a quick look, see what you find. Okay, so powers of 2. 2 times 1, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Well, there we are. It is the fourth one. So x is equal to 4. And here's a weird one. This would be like a 4+ question. So if this one throws you, don't feel bad. I won't be giving you this type all the time. Let's go purple this time. So we want to express this power as a different power, as a power with a different base, as a power with a base of 4. So how would we do that? Well, we're going to look at what power of 4 is 64. So we'll start by trying to find what power of 4 would give us 64. And from over here on the left, we can see it's cubed. So 4 cubed is equal to 64. So since these are equal, I can substitute 4 cubed in where 64 is. So what does that mean? Well, 64 to the power of 5, we do our substitution, is 4 cubed. So that's 64. We still have to have that to the power of 5. And then we use our power of a power rule. Our base is 4, and our exponent is 3 times 5, 15. So 4 to the power of 15 is the same as 64 to the power of 5. I don't think I'll do a big explanation for the rest. Try them, and then I'll post the answers so you can double check. And that'll be it. There's lots of practice problems for yesterday, lots of practice problems for today. Power rules are a handy thing. They're not going away. They're going to pop up here, there, and everywhere as you go through math. So it's really worth taking the time to devote to it to get comfortable. All right. I should be back tomorrow, and we'll talk to you then. Bye.